Hey guys, so today in class we completed a lab to model the different types of plate boundaries. You can find all of the papers, the lab guide, the student questions, everything in this Google Classroom post. So first thing we did was we took some icing and we spread it on our plate. And this icing, because it's kind of like molten and gooey, it represents the asthenosphere. So right below the lithosphere, the crust, is kind of that like molten layer. Then we took 2 pieces of fruit by the foot and we laid them on top of the asthenosphere. And these pieces of fruit by the foot represent oceanic crust. So it looks like this. And then we first modeled a divergent boundary. And remember that divergent boundaries divide, so they're moving away from each other. So I'm gonna take my 2 pieces of fruit by the foot and I'm gonna move them away, but I'm gonna kind of press down because I want that icing to come up between those 2 pieces to represent magma coming up through that crack in the crust at a mid-ocean ridge. Then we took our 2 oceanic boundaries and our oceanic crust and we moved them towards each other to represent a convergent boundary. And you can see when I do that, I have to kind of finagle it a little bit. That one of my fruit by the foot pieces went underneath the other. So remember, we call that subduction. And then you can also see that some of the icing or the magma came up with the plate that was on top, which happens at those convergent boundaries. Often we get magma that comes up and creates volcanoes at those boundaries. So now I'm gonna replace a fruit by the foot piece with a piece of graham cracker. And I'm gonna create a convergent boundary out of an oceanic crust, and our graham cracker represents continental crust. And when I move those towards each other, my graham cracker goes over top of my fruit by the foot. And the reason for that is that graham cracker crust represents continental crust, and we know that continental crusts are less dense than oceanic crust. So when those 2 meet, the continental crust goes over top and the oceanic crust subducts because it's much more dense. Our last convergent boundary that we're gonna do is a continental convergent boundary. So 2 continental crusts that are colliding. So I'm gonna take 2 pieces of graham cracker and I'm gonna dip them in water for just a couple seconds. And then I'm gonna take those 2 pieces and I'm gonna take the wet ends and push them together. So you can see that both of the graham crackers push each other up. So we get a mountain when a continent and a continental crust collide, we get mountain building. Our last type of boundary that we have is a transform boundary. So a transform boundary is when 2 plates slide past each other. So I'm gonna take 2 continental crusts and I'm gonna slide them past each other. And not much happens. You can see that there was some like grinding, some of the graham cracker kind of crumbled off. And at transform boundaries, regardless of the type of crust, we are always gonna get an earthquake.